Hello, in this tutorial I'm going to be going over how you rationalise the denominator. So here we have a fraction, we have 2 over root 3. Now what we mean when we say rationalise the denominator, that means that we want a fraction where the denominator, so that is the number at the bottom of the fraction, is a rational number. At the moment, this fraction has an irrational denominator. That is, root 3 is an irrational number. Now just to recap, an irrational number is any number that cannot be expressed as a fraction. So that is where the numbers beyond the decimal point go on to infinity, and therefore it cannot have a representation as a fraction. So for example, if we had the square root of 4, well, the answer to this is 2, because 2 times 2 equals 4, so therefore this is not a surd because it is not an irrational number. Root 2, if you were to put this into your calculator, you would find a number that begins 1.4 and a long string of decimals, and this cannot be expressed as a fraction, so therefore it is a surd. So moving back to the fraction we have here, what we want to do is get rid of any sign of the square root symbol or the root symbol in our denominator. Now just to recap surds, you will remember that if you had the square root of a number multiplied by the square root of the same number, the answer is just the number itself. So i.e., if we had square root of a multiplied by the square root of a, that would give us a on its own. Now this is important because it means that this gives us a way where we can get rid of the square root symbol in our fraction. So what we're going to do, we are going to multiply this fraction by another fraction where the denominator of the other fraction, so this new fraction, is also root 3. Now all we are doing is rationalising the denominator. We don't want to actually change what the fraction itself represents. So we still want the end result to be equivalent to 2 over root 3. So what we do, when we multiply our original fraction by this new fraction, root 3 remains the denominator. Now if we use root 3 as the numerator, then essentially what we're doing, so if I box off this fraction here, what we're doing is multiplying our fraction by 1. And we know from basic maths that any number when multiplied by 1 remains the same number. You don't actually change what the value of the original fraction in this case represents. So this provides us a way, by using this rule here, to get rid of our root 3 without actually changing what the whole fraction represents. So if we work through this question now, using our rules of fraction multiplication, so you multiply along the top, you multiply along the bottom, and put those respective numbers in this new fraction. So we'd have 2 multiplied by root 3 at the top, root 3 multiplied by root 3 in the bottom, and that will give us 2 root 3 for the numerator of our new fraction. So just 2 lots of root 3 is 2 root 3, and root 3 times root 3 is just 3. And now we have a case where the denominator is no longer an irrational number, so 3 is a rational number, which is what we wanted, and the topic is rationalising the denominator, so the fact that the numerator is now irrational doesn't matter. And if you were to go to your calculator and put in 2 over root 3 and note whatever value that this gives you, and if you go to your calculator and type in 2 times root 3 over 3 and note whatever value this gives you, you'll notice that they will be exactly the same. So that's all there is to it in terms of rationalising a denominator, where the denominator is just a square root on its own. So that is, in our original question, root 3 was on its own. So let's just do another example. if we had 3 over root 7. So what we do here, so we maintain our original fraction, we multiply that by a fraction where the denominator is the same, the numerator is the same, so therefore we're multiplying it by 1, so we're not actually changing what the fraction represents. And then by rules of multiplication with fractions, this becomes 3 times root 7 over root 7 times root 7, which becomes 3 root 7 over 7. And therefore, this fraction is still the same as this in terms of what it represents, but our denominator is no longer an irrational number. So I'll just give you 2 questions for you to try yourself. So this time we're going to have 10 over root 5, and let's have 3 over root 13. So if you'd like to pause the video now and then unpause it, and we'll go through the answers when you've had a chance to go through the solution yourself. Okay, now the video's unpaused, let's work through these questions. So here we had 10 over root 5. So we would multiply this by a further fraction where root 5 is both the denominator and the numerator. So this is essentially 1. This will give us 10 root 5 over 5. Now this fraction here can be simplified, and that will give us 10 divided by 5 is 2 root 5. Now with this question, again 3 over root 13 remains. Multiply that by a fraction where root 13 is both the numerator and denominator. This will give us 3 root 13 over 13. This cannot be simplified, so that is the final result. Okay, in my other videos on rationalising the denominator, I will go into questions where you have, for example, a normal numerator as we have done before, but where the denominator is made up of parts. So for example, this form, and the other form is where you would have, for example, a surd forming part of the numerator and a surd in the denominator. So as I just said, these are your basic form of when you have to rationalise the denominator, and in my next video on surds I'll go through how you rationalise these sort of questions. Okay, if you have any comments then you can leave them in the comment section below. Okay, thank you.